everyone. Today we are going to be talking about a very important stage in data science lifecycle. That is none other than feature selection. Like the name itself suggests, it's a method where we decide what set of features we want to consider in our model development or we should be considering in our model development. Now, why is that important? For example, let's say there are 500 features. Not all those 500 features will contribute significantly to fit our model. That's where it becomes important that we decide which set of features that we should be considering for our model development. For this feature selection, there are a set of techniques which has been provided. And if you combine or maybe categorize all those set of techniques in segments, broadly you may come up with these three segments, which are filter methods, wrapper method, and embedded method. Now, what all are the techniques considered in each of these three segments? Let's start with the first one. Filter method comprises of these three techniques. Similarly, wrapper method comprises of these all five techniques. Embedded method is comprised with these five techniques. Today we are going to be looking at or focusing at filter methods, out of which first of all we will look into the correlation based methods for feature selection. If you are brand new to statistics or data science, I highly recommend you to go ahead and check out this video, which will give you a fair bit of understanding about correlation, what exactly the correlation is. However, if you don't want to pause this video and go and check this one, I can still give you some bit of understanding about the correlation. Consider this feature which is talking about the temperature. What you observe is temperature is increasing by the time. First of all, it is having 26 degree, 28 degree, then 30 degree, and then 35 degree. Accordingly, there is another feature which is nothing but talking about sales of ice cream units. And if you observe, that is also increasing as the temperature increases. What you can see is both of these two features are moving in the same direction and having strong correlation. So this is where we see both of these two features are correlated and both of these two are traveling or maybe moving into the same direction. But it's not important that all the time both of these two features are moving in the same direction. It can be moving into the opposite directions as well. For example, with the increase in temperature, the sales of the woolen cloth falls. So here, if you see, both of those two features are moving into the different direction. However, still both of them have the correlation. And in that situation, it does not make much sense to keep both of the two features in our training data set. Ultimately, if you see, both of these two data sets are resulting into the revenue, and revenue is also correlated with these two. However, revenue is our target feature, so we will not be removing that. While we are talking about temperature and ice cream, we should be also considering which of these two features are highly correlated with revenue. The one which is highly correlated with revenue, we should not be considering to remove that, because that would have a great influence on the target feature. So the first stage is to find the correlation among the features, identify the pair of the features which are having correlation between them, and then see out of those two which one is strongly correlated with the target. Keep that, remove the other one. If neither of those two have significant impact on the target variable, discuss it with the business, and taking basis on that, you can take the decision to remove it, or maybe basis on your experience. But when you decide to remove the feature, that requires the significant amount of discussion and brainstorming. All right, let's jump to the Jupyter notebook and try to understand with the real example. Here, when we are starting, it is very important that you consider importing all of these dependency first of all. What you see, these are the basic libraries Then here sklearn modules I have imported, and this is some of the options which I have set over here. This is the breast cancer dataset which I have imported or maybe downloaded from Kaggle, and the link is something which I will be providing into the description. Otherwise, if you are particularly interested into the data, I will upload it on GitHub and I'll share the link. Moving on, some of the treatment that we require to do on this data, first of all, which is ID, second is diagnosis. ID is something which is not required for our model development, and this is having the character value which is M and B. So we need to code it. This is the target feature, but having the value in characters, which we need to encode in terms of binary, which means it should have the binary value, which is 1 and 0. Let's understand its meaning. So here is the Kaggle page from where I have downloaded this data. So here M stands for this, B stands for this. So this will be having value as 1 and this will be having value as 0. Let's go ahead and try to do this, perform these treatments on this data. First of all, we will drop this particular ID column. Cancer df equals to df dot drop, and inside that I'm going to say ID axis equals to 1. And let's have a look on this data frame. That one is gone. Next step is to encode the target variable, and I'm going to keep the variable name or the feature name same as it is. And the next thing is do this. Before this, I can use np.where, np.where, and it is just like if else condition which you might have used in Excel. Just put the condition first, which is cancer df diagnosis. If this is having value of M, then what exactly that you need to produce is 1, otherwise 0. That is done. Here is what we got. Next step is to do the trend test split. So for that we have this module from sklearn library. Inside that, but before this, we first need to split this data in target and in the set of features. So that I will do right over here. For example, over here I would say inputs equals to nothing but cancer df dot drop. Inside that I'm going to put diagnosis, this feature, and axis equals to 1. Means in the input data which we are going to supply for training the model or to train the model, out of that I'm just simply dropping the target feature. That is it, nothing else. And in the target set of the data, I'm going to particularly continue or keep that feature only, diagnosis. Now let's just see inputs dot head. What is that we got? The diagnosis feature is gone, and in the target we have only that feature. Awesome, we are done with that. Next, trend test is split into that first data frame which we need to apply is inputs and then the target feature. And then here we need to set the test size. So usually test size depends on you. Usually we take it, somewhere 10 to 30%. Here I'm going to keep it 20%. And then random state is 42 conventionally, which is x train, x test, y train, then y test. This is the data split which I am doing over here. We are done with this. We can quickly check x train dot head. We got this set of features. Next step which comes is to perform the feature selection. Remember, when we are performing the feature selection, we should be doing that on training set of data only. What I mean is feature selection means dropping or keeping the specific feature, right? Which feature to keep, which feature to drop. That is something which will be performed on both of the data set, that is xtrend and xtest both. But when we are doing the analysis to drop or select that should be performed on xtrend data only. This is to avoid the data leakage or overfitting of the model. So when today we are going to focus on correlation technique, and that's something which we need to be performing on. So we will be trying to find the correlation among features using xtrend data only. Remember that. Now over here, simply I would say xtrend dot core. So this dot core is nothing but the formula or function to find the correlation among features in the given numeric features in the given data. This is what it is, right? Core equals to, so core is nothing but the data frame. Let me name it like this, core df, and this is what we got over here. Let's just see this. All right, so it's kind of little hard to figure out which one is having correlated. You need to dive deeper into it and figure out where the correlation, what is the correlation percentage. For example, if you see over here, it is 53%, which is okay. Now if you would see, some of them might be having some 99% of the correlation, which is between perimeter mean and the radius mean. All right, so this does not make much sense to keep in our model training. With this, radius mean is having a strong correlation with the area mean and perimeter mean both, which does not make much sense. If you see over here as well, how can we visualize it well? So for that we can use SNS, which is nothing but the seaborn, which I had imported at the top. And over here I'm going to use heat map visualization, and let's run this. Let's see what is it that we are getting. You see, this is what we got. Now the darker one is having the strongest relationship, and the lightest one is having the strongest relationship, negatively and positively. If you see, this is minus 0.2 and this is 1. All right, now the next thing is to make it look little better, where we would display the numbers as well. For that, first of all, we need to make it little bigger, and for that we need to use matplotlib plt.figure, and inside that we're gonna use fig size, which is 15 by 5. This is the size which I'm going to be specifying over here. Still this looks little smaller. I'm going to say 10. This is better. Now the time comes when we need to put the numbers inside this. Annotate equals to true. And let's just see what is the size that we are going to get. Ooh, this looks too clumsy, isn't it? We can increase the size further a bit more. Here is the parameter. Here one of the parameter which says how to specify the decimal place. Let's just put this, and over here I would say, let's see what happens. It says it is not asked. There's something called 0.0f, and if you run this, and then after that I'm going to specify some annotate keywords as well, and that needs to be specified in dictionary. And over here I'm going to say size equals to, let's say 10. Let's see what happens. What is that we are going to get? Pretty well. So here we are getting all of these things in. Here 0f means 0 decimal values, right? This is another page which I have just opened, which is completely about heat map, and I will put a link of this video also into the description section. 0f means 0 float, and here we require 2-digit float. So let me just put 2f and let's see what happens. Again, it is looking too clumsy, right? Let me make it 20 wide. Still better, but not much well. But anyway, we can do the decoration of it. I will put the link of the heat map video and you can focus on that and you can accordingly find this. What we need to focus is over here, the darker and the lighter area, right? See, the darker one is having the negative most correlated features, and the lighter one is having the positive most correlated features, right? For example, you see this is 81%, this is 99%. Okay, this radius mean, and here is the other one which we have. Okay, so accordingly this is how you can visualize the correlation in your data. Now moving on, we would require to find out and list down all those features which are having the correlation. So when I say having correlation, that's a very generic statement. We need to have a threshold, which threshold that we want to specify, where we would say, okay, after this threshold, if it is having some correlation, we will drop that feature, we will consider to drop that feature. So here I'm going to create a blank list which is called for, or let me just say that threshold I'm going to keep 90%. Whatever the features which are having the correlation of greater than equals to 90%, I will be considering to drop them. Here I am the only business who have to decide it, that's why I'm taking this call. If you're doing it in your job, you need to first figure out you need to discuss what is the percentage of threshold that the business want to consider, or maybe you can provide your suggestions that this is not good and this is not good, this is good to keep. Okay, and basis on that you can come up with a feature threshold value, and then identify the features which are having the correlation greater than equals to that threshold value, and then discuss that with business. All right, let's just move on. Over here I would say for I in range len core dot columns, and then over here, so what I'm doing is this loop will go like this. Then I would say for j in range I to go vertically, and I would check out if core dot ilock, this I'm doing for to find the intersection. So if I say I comma j, which means this intersection, we get starting one, I mean any of the intersection. All right, starting from here or here, the intersection point, right? Where, and at the, like you can see at the intersection point only we have some values, right? So that's what we are trying to identify over here. If this is greater than 0.9, which is nothing but 90%, then what should we do? We need to create a blank list first of all. Over here, correlated pairs equals to blank list, and into that we will keep on appending dot append. Inside that I would say core dot column, and take I comma core dot column, then take j, then comma core dot ilock, and over here take I comma j. All right, this is the list which we have got. After that, what we need to do is core pairs, and let's just print that. So here is what we got. These are the features which are having the correlation greater than equals to 90%, right? You can see all of them are having greater than 90%. Now you see this is the pair of the features. Now we need to decide which segment of it we want to keep and which one we want to drop. So that's something, like I said, you would require to have a discussion with business. Here I am the only one, so I'm deciding to keep this all features, sorry, to drop these all features and continue with the second one. Let me do that. So for that, first of all, I need to extract these all features. For that, what I can say is, in this list, if you see, you have elements as packed as tuples, right? So we need to iterate through each of these items. For that, what I can do is, you can say for I comma j comma k in core pairs, And here I would say, let me create again features to drop. Again a blank list. Oops. And over here I'm going to say features to drop dot append, and here I will just put I. Now let's just see. This is what we got. Now what you observe is there are duplicates into it. So to make that unique, what I'm going to do is, let me just try this if it works. Here I'm going to say set is something which will make it unique. Let me show you that. So now you see it is unique, but again we need to keep that into the form of list so that we could drop that easily, right? So that I'm going to convert it as list. That is converted, and let me see if I can store that in the same list again. Here is what we. All right, now we are done with identifying the features which needs to be dropped. So let me create another set which I would say xtrain selected. Okay, and after that I'm going to say xtrain and dot drop, and over here I would supply this set of features, this all set of features to drop axis equals to 1. Let's see if this works. What do you think? It's gonna work? Looks like it worked. Let me see the shape of it. Oops. Here 20 we got. Right, now what you see over here is, here we had 32 features, out of which we dropped this one, we left with 31, and then we separated this one for target features. So we were left with 30 features in xtrain, original xtrain, in this data set, right? And over here we are left with 20 because these were the 10 features we just dropped. If you see 1 2 3 4 5 6 7 8 9 10. Now we should also be considering to drop this from test dataset. Like I said in the beginning, we can do the analysis on training dataset only, but when we are dropping the features or keeping the features, then that's something which we need to perform on test dataset as well, right? So let me just do that on test dataset as well. So here I would say x test selected, x test. All right, now over here as well I would say test. Got it. Bravo. Now the next step is to develop the model. Here what I'm going to do is, I'm going to develop two models one by one. First I will develop the model train and test the model basis on train data, and then I will develop and test the model basis on the train selected features. Okay, let's just start it. Logit equals to logistic regression. This is the instance created. Then I'm going to say logit dot fit, and inside that I'm going to use xtrain comma ytrain. This is also done. Next is prediction, and the prediction which I'm going to make is logit dot predict, and over here I need to provide x test. Prediction is done. Then time comes to print the classification report, and inside that I'm going to put y test, then prediction, and let's just see what is it that we got. Let me try to print this so that it could look pretty. Here you see you have the F1 score and all these things approximately near to 100%, right? So you see over here it is 98 for positive and negative both of the classes. Let's see what is the difference that we have, how it works on, you know, the data where we have dropped the features. These two segments I think I have covered over here only, so I will delete these two segments. That does not make much sense. Now over here I'm just going to create another instance of this one, logit selected. This is what I'm going to say. then I would say logit selected dot fit, and inside that I'm going to say xtrain selected. This is done. There seem to be some issue. Xtrain, oops, I need to provide y train as well. Y train, that is done. Next we need to make the prediction. Logit selected dot predict, and inside that I'm going to use x test selected, x test selected comma y test, and let me store it prediction pred selected equals to this. This is all. Here we don't need to provide a y test because we are just making the prediction, right? When we print the classification report, then at that point of time we would require that. So we are done with doing the prediction on selected features. Now let's just see how does it looks like. Over here we need to provide y test and then predicted prediction selected. Let's just see how it looks like. All right, so if you see the variation over here, 95, 93, 94, and over here what we had is 98, 93. So here the variation was quite significant, I mean relatively huge, 98 to 93, and over here if you see it is 95 to 93, which is still I can say is little better, okay, and 94 is over here against to 95. So over here there could have been some possibility of overfitting, which I think we have eliminated over here, though the numbers are quite close to each other with some difference. Accuracy remains unimpacted, but you are aware that this is something which gives much better picture. So this is how you can perform the feature selection using correlation method. I hope it was clear. I'll quickly summarize it to you. Here we imported some pre-dependencies. Here we imported the data. We just saw the data samples. Here we separated, here we dropped the not required features, which was basically on our understanding, and here we just did the encoding of the target feature, and then after that we separated the inputs and target, and then after that we did train tester split. On the training data we tried to find the correlation. We visualize that using Seaborn library. Again, I would put this notebook also into the description section. I would highly encourage you to go through this. I'll put a video also for this one, and you go through that and try to understand about the heat map if you want to know further detail. And after this visualization we try to find all those feature, all those pairs of feature where they have correlation greater than equals to 90%, okay, which gives us this list. Out of that we separated the list which we wanted to drop. We make a unique list of that, and then we drop those features from train and test both of the data set. Remember, the analysis was done on training data set only, but the selection was performed on both of those two, okay. Now after that we did the training of the model on only train data set, and we created the classification report. Then again we did the same thing on dataset where the features were selected after correlation analysis, okay, and then we checked that also. We compared and we found a little variation, but there was variation which looks meaningful. Now that we are done with understanding the feature selection technique with the correlation method, time comes to relook into the data once again and try to understand a very important point. So what we should understand over here is, in this data frame, if you have a look, all of the features are having continuous values. Now think of another data frame, this, which is having majority of the features as category features, categorical features. Now what is the technique that can help over here to do the feature selection? Because what we saw previously, that was correlation, and that was useful for continuous features. So that's where we get the next technique, which is chi-square test. Now this video I'm going to split in two parts. In first part, I'm going to cover how would you calculate chi-square by hand or manually if you don't have any technology, because that is very important to understand the techniques or algorithm behind the syntax or codes which you are creating. Though the technology has simplified the work, but it is understand the it is important that we understand the algorithm which is running behind it. That's where in the first part I'm going to cover the logic or algorithm behind chi-square, and in the second part I'm going to do the implementation in Python. If you are interested in only in second part, please feel free to skip the half of the video and continue watching the implementation in Python. Alright, let's just start. In chi-square test, to understand this, let's take a sample data, this, which has just three features: employment, education, and loan status. The last one is the target feature. First two are the input features. What we have to identify is the alternate hypothesis says that the education is influencing loan status, which means higher the education, possibility to get the loan is greater the possibility of getting the loan approved. So to evaluate this, what we do is we try to observe the count of this data, and we come up with this kind of observation. In this data frame, you have 100 records and 3 features, 100 rows and 3 features. So when we summarize that, this is what we get. Now, if you see over here, for postgraduate, there are 18 approved, 9 declined, altogether 27 applications. Null hypothesis says, no, this is not true. The condition, whatever statement alternate hypothesis is saying, that is incorrect. So we come up with two statement. First, null hypothesis, which says there is no significant relation between education and the loan status. Second one is alternate hypothesis, which is represented by H1 or H alpha, which says that there is significant relation between education and loan status. This is what we have to prove through chi-square calculation. If you observe a word which is coming again and again, that is significant. What is this significant? So that is nothing but you can just consider a number which we have to specify that if anything which is coming greater than this, then we will go ahead with the alternate hypothesis, or less than this we will go with null hypothesis, etc. Anything which that's we can consider that it's a condition, right? So let's consider over here the significance level I'm going to consider, which is 0.05, which is the ideal situation. This is also called the p-value, right? This is an ideal situation where we usually take the significance level at 0.05, which is 5% also. Hope this is clear. Now let's move on and try to calculate the chi-square. Now, first of all, when we are proceeding with calculating the chi-square, we need to have a expected value for this observed value. This table which you are seeing, this is observed values or observed tables. We need to create another table which is having the expected value. Expected value is nothing but the probability of something happening. For example, what is the probability that 18 postgraduates will be approved? To find that, what we're gonna do is we're gonna take row total multiplied by column total and divided by grand total. Which values are those? Those are 27, which is row total for postgraduate, then 54, which is column total for approved. Then we are going to take total number of rows available in this data frame, which is 100, and ultimately we come up with this value, which is 14.58. Exactly the same thing we are going to repeat for each of the rows and each of the columns. In the next step, we will calculate for graduate, and for that we will do the multiplication of 24 into 54 divided by 100. So after doing this calculation, we come up with this table. What you observe over here is this is the value which we just calculated. Similarly, it is calculated for graduate, for approved, and same way it is calculated for decline also. Next step is to calculate the chi-square value. To calculate chi-square value, this is the formula which we use. Over here, if you notice, this O represents to the observed value. Observed values are something which are available over here. E represents to the expected value which are available over here. So what we are precisely saying is observed value minus expected value and divided by the expected value. And whatever we get, we need to sum up them all. Let me explain you this further. This is our observed values and this is our expected value which we got using this formula. Let's move ahead and try to solve this. So when you try to solve, this is the table which you will get. Let's go by this table one by one. First column is observed values. So if you see from 18 to 6, that is given over here, 18 to 6. Then 9 to 7, that is given over here. So all the values, whatever the columns that you have, you need to put the value from each of those columns one below another. Same way you need to do it for expected table as well, expected values as well. So you see over here, these values are mapped against these values. It is very important. You should not be doing incorrect mapping, right? So this, let me help you understand once again. These all values should be subtracted from these values. That's something which we need to notice. So first one is observed value, second one is expected value. Here comes the difference, observed minus expected, and this column contains the squared of this difference, and this column contains a squared value divided by again the expected value. And when we sum them up all together, what we get is 3.62. This is called x, not x square, but the chi-square calculated value. We just got chi-square calculated value. There is another value which we need to find, and that is x square tabular, which is chi-square tabular value. To find that, what we require to have is degree of freedom. Degree of freedom is nothing but the option. It simply says that how many options that you are left with to move ahead. To find that, what we do is number of rows in the expected table minus number of rows minus 1 into number of columns minus 1. So over here you see, either here or here, doesn't matter, either in expected table or in the observed table. What we require to consider is this area into this total column. We don't need to consider. So you see how many number of rows that we have, 5 minus 1, which will be 4, and number of columns that we have is these two, approved and declined. You don't need to consider this education. Okay, number of columns minus 1, then we are left with 1. So this is the number which we get, which is 4. Degree of freedom that we have is 4. Now for this we need to find the chi-square tabular value. To find that, what you need to do is simply go on Google and try to search chi-square distribution table, and you can open any of these. I have just opened the first one. Before we try to dive into that, let's just understand we require two values to look for a chi-square value in the table. For that, first one is degree of freedom, and second thing which we require is significance level. Significance level we have 0.05 and degree of freedom we have 4. Let's go to the table and try to find degree of freedom. Here we got 4 and significance level over here 0.5. You see, this is the intersection of both of these two, which is 9.488. So this is what we got. This is the value for chi-square tabular. Now we need to compare both of these two, chi-square calculated and chi-square tabular. If you see, chi-square calculated is less than chi-square tabular, which means the alternate hypothesis is rejected. This rejects the alternate hypothesis, which means null hypothesis is true, and that means ultimately that there is no relation between education and the target feature, which is loan status. There is no relation. The education is not influencing the target feature. This is what the hypothesis, this chi-square calculation makes. I hope this is clear to you. In case of any doubt, put that into the comment section. Now, what does this mean? I just explained that here the education is not having any significant relation with loan status basis on this calculation or basis on this analysis. I hope again that the calculation method was simple enough to understand it. In the next step, I'm going to take you to the Python, and over there I'll show you how to implement this on data. Here in Jupyter Notebook, before we start further, you need to make sure that these all dependencies are available, installed, downloaded, or whatever you want, and imported properly in this session. Now here is the data that I'm going to use. I will upload this data on GitHub and will share the link in the description section. You may feel free to check that out. Next thing which we need to do is, out of this data we need to find all those features which are categorical. Like you can see, some of them are numerical, but we are going to be focusing on categorical only. Okay, now so for that categorical, I am going to take senior citizen. I see this is also categorical, but for now I will not focus on this. I'm going to look on only those features which are having the alphabetic values. Okay, now let me just very quickly say categorical cat features equals to df dot select data types, and over here I'm going to say include, and out of this include, what is it that we want to include? We want to include, come on, tell me very quickly. We want to include object. All right, and now let's just see what is it that we got over here. We got all those features where it is object. These are the categorical features. We don't require this customer ID, so I will quickly drop it. And here I would say access equals to 1. That is done. We are done with finding this one. Now the next step, let's very quickly check whether either of these feature are having any missing value or not. Is null dot sum. So none of these features are having any missing value. That's a good news. Moving on, what we will do is we require to convert this all, because the model will not understand these character values. We require to convert it into numbers. So for example, if you see, let's just try to find the unique values. Which feature is having how many unique values? Okay, cat features dot n unique. All right, total charges, my god, total charges are having 6,531 different values. I'm not sure what those values are. Let's just have a look on that. Cat features dot unique, sorry, total charges dot unique. Oh, categorical features, I don't think this total charges is needed, because this seems like a continuous feature, isn't it? So we will drop that also. That is not needed, though, because of some data type issues and etc. that is coming over here. So I will include this also over here. That's a continuous feature and should not be treated as categorical feature. That's a data type issue, that's why it is coming over here. So if we are implementing the models, that will come in the data cleaning part, which I have skipped over here, because here we need to focus on chi-square. Now we are done with this. All right, then you see the maximum unique value, the feature which is having the maximum unique value is 4. Looks pretty good. Next thing which we need to do is convert this all into numbers, either 0, 1, 2, 3, etc. So for that we have label encoder. Label encoder we have already imported. Where can you find that label encoder? That is available in sklearn pre-processing. Here is the label encoder. Next one, I'm going to create an instance for this label encoder. Next, I would say encoded data frame I'm going to create, pd dot data frame encoded, and here I would say for column in categorical features dot columns. So here I'm simply taking the list of all the columns from categorical features and iterating through each of them. Encoded, here I will create another column, and over here I would say label encoder dot fit transform, and inside that I can just put call. Let's just see what is the error. Why should be 1D array got 2D arrays? What's the challenge? It should not be. All right, I made an error here. It should be like this. Method object is not subscriptable. What's the issue now? All right, so it should not be, it should be like this. Why I'm making such a silly mistake? Cat features. Now this is done. Encoded dot head. Super, we got our values encoded. Next one we are going to be, next we need to split this data in train and test split. So there is another method, not method, but this module which we need to use, train test split, that you can import from sklearn model selection. Over here what I'm going to say is train test split, and into this I'm going to provide the data encoded. So out of this we need to exclude this target feature, which is churn. This is the target feature for us that I need to just exclude from the input. So first we need to supply the input, then we need to provide the target, both of these two things, right? So over here I'm going to say encoded dot drop, and inside that this column is something which I want to drop, which needs to be looked on axis number 1. That means column. Now over here I need to use encoded, and out of this I only require this particular column. Test size I need to provide, I'm going to keep 20% of the data as test size, and then random state I'm going to use 42. You can use anything, but if you want to get the result same as I have, then please use this proportion. Okay, now over here I need to create xtrain comma xtest, and then ytrain comma ytest. This is done. Let's have a look at xtrain data dot head. They should not be having the churn column into it. You see, it is not having that. Now we are pretty good to calculate the chi-square. Chi-square over here, and inside that we need to supply xtrain. Remember, to do any sort of this feature selection analysis, you should always perform that on xtrain only. Though when you are eliminating those features or keeping those features, you would require to do that on both of the set, which means on training and testing both of the set. But when you are doing the analysis, you should be performing that on xtrain only to avoid overfitting or data leakage. You can also say xtrain comma ytrain, and I'm going to put it in chi-score data frame, rather you can say, okay, or the feature. So here is what we got. So you see, it is a two-dimensional array. Into this, first one is showing you the chi-square value, and second one is showing you the p value. So which one to keep and which one to drop? So greater the score for chi-square is better for us, and lesser the p value is better for us. So what we need to find is, this is showing the relation with your target feature, not with each of the feature. Remember, in correlation we were trying to find the relation between each of the feature and with target feature also, but over here it is taking each of the feature and trying to find the relation with target feature. So hope that is clear. Now let's just move on and try to visualize this. Okay, so here I'm going to say chi-square score dot chi-square dot index. No, not this. We need to convert this into series, right? Because currently it is array, we need to convert this into this series. So how can you do that? So for doing that, you need to say pd dot series, and inside that the first element we need to grab after out of chi-score, and that is 0. And then we need to supply index value we can directly take from xtrain dot index, and let's just say chi-square score underscore series. All right, same thing we will do for p-value also. Over here I just need to make 1, that is it. And over here I can say p-value, let's keep it in small letter only, p-value series. Looks like it is done. Chi-square score series, this is what we got. And then p-value series, this is what we got. I will also do the sorting of this data. Sort values, ascending equals to false, because I want to keep that in descending order. And over here I would say sort values, and here I would keep it in ascending order because we need to see the smaller one at the top. Now this is done. After this, what we require to do is we need to do the visualization. All right, this does not look correct. Here I need to say columns. All right, everything is having same sort of feature, same sort of chi-square value. How could that be possible? All right, I had made a mistake here. The variable previously which I had was chi-square score, right? While originally which I had created was something else, right? So that's what I just changed. I have taken this and I'm putting it over here, and then you see this is the data which I got. All right, if you want to round it, you can do the rounding of it also. I'm going to keep it keep this as it is. Now I will quickly try to plot it using SNS is nothing but the Seaborn library. Let me see if I have imported it or not. I'll quickly import it. Import Seaborn as SNS, import matplotlib.plt as pyplot. Done. matplotlib.plt. What's wrong? No module name. Matplotlib. Why is that so? Let me see. We can do. All right, the challenge was here. I was right. I had written plt. Ideally I should write pyplot. Okay, now let's just come down over here, and again I'm going to say his plot, and on x-axis I'm going to put index. Next on y-axis I would put, why I'm using p-value, rather I should be using this one, isn't it? Yes. And then over here dot values, and this is what we got. Now to make it look better, okay, and let me just show you this data also first. You see, now this is readable. So what you see in this data is, this is the most important feature. It is having a great relation with the churn feature, which was our target, and this is also is having great relation. All these three are appearing to be having great relation with this, with the target feature. Now over here you saw this is how we have plotted it. To make it look good, I'm going to do quick thing, plt dot figure, and inside that fig size, and I would say 15 comma 5, and here I would say plt dot xticks rotation rotation, I'm going to keep it 90°. Now you see this is looking pretty clear. Over here what you see is this first one, contract is having the highest score. That means that is the most important feature. Okay, then these two, then this one, right? So approximately these four are showing relatively the great relation compared to the rest of them. So rest of them is something which you can feel free to drop or not keep while you're training, or maybe you can do the simulation. And over here these are the features which are most important. My recommendation will be to go ahead with these three features, right? All that you require now to do is just simply drop these features from your data train data frame, and then utilize that in utilize remaining data in training your model. Okay, now over here let's try to plot the p-value as well. Let me see if this is going to work. Over here let me see if both of these two can come. So this appears to be, let me put that in a separate one. It's not coming over here. And let me put this over here. Again the same thing I will put over here as well. All right, now what you see over here is, again it is showing the similar result, right? It is showing the similar result, means this was in ascending order. So these are the features which are having least p-value, and these are the same are the features which are having the highest chi-square values. So you see both of these two are quite in sync. So yeah, the analysis is pretty well. You can just go ahead and drop this I mean you can just select these three features to train your model, and you can go ahead with the implementation. So here I'm not getting into training the model and testing it. I'm keeping it simple to the feature selection only. Let me know if you'd like me to cover that part also in each of the feature selection. We just completed understanding the feature selection with chi-square method. And why did we use chi-square method? Because over here we had the target feature as categorical and independent feature also we had as categorical. That's why we had to use the chi-square method, because in correlation method we were needed to have the independent features as continuous feature or numeric feature. All right, hope you remember. Now let's think of another situation where we have the target feature as continuous and the independent features as categorical. For sure we cannot perform correlation over here, and because the target feature is also continuous and these are categorical, so we cannot perform the chi-square also. What exactly that we should have the option? We come with this question, and that's where the next analysis, which is ANOVA analysis, comes into the picture. What does ANOVA means? ANOVA means simply analysis of variance, right? So here over here we just try to understand what is the variance that we are having in different categories, between different categories and within the categories. Now there are two terms which I just threw. First one is what is the variance between categories, and the second one is what is the variance within the categories. What does that mean? If you look at this data, this is loan amount data, I mean loan application data, where loan amount is the target feature and age is the independent feature. So we are trying to establish whether age is having strong relation with loan amount or not. That's what we need to establish. So if we want to perform the ANOVA analysis, what we need to figure out is how many categories are available in age. So like you can see, I have done the binning on age. So if you find there are 5 categories of age. First, less than 20, then 20 to 30, 30 to 40, 40 to 50, and then 50 plus. Right? So what we need to find is, first we need to find the mean of each of these categories. Then in the first we need to find the variance between the mean of each of these categories, and then we need to find the variance within each of these categories. Don't worry, I'm just going to explain this thing in very detail one by one. But before that, let's make an hypothesis. Hypothesis is, null hypothesis says that there is no relation between age and loan amount, while the alternate hypothesis says that there is relation between age and loan amount. There is significant relation. And like you already know, if we are talking about the hypothesis, we need to determine a significant level, significance level. So this is the significance level I'm going to consider, which is usually used, right? Let's move on. So to proceed further with ANOVA analysis, like I did in the previous video also, I did the video in two part. In first part, I try to do the calculation of chi-square manually by hand, and then I try to implement the same thing in Python. Same thing I'm going to do over here. If you are not interested in understanding how to perform the ANOVA by hand, you can skip first part of this video and you can continue watching the second half of this video. All right, second half of this video. Let's start with this. If we are performing the ANOVA analysis with hand, there are two things that you need to calculate in the first stage. First one is sum of squares error. Second one is sum of squares between. What does this mean? I'm going to explain one by one. I'll start the second one first. Sum of squares between. What does that mean? Means the mean which you have got for, first of all, you have to find the mean for each of these categories, each of these age category. Then you need to find the grand mean, and then you need to find the difference between grand mean and the mean which you have got for each of these categories. Let me help you understand. Now have a look on this. You see there are 5 categories I have over here: less than 20, 20 to 30, 30 to 40, 40 to 50, and 50 plus. And for each of these category, I have calculated the mean over here. For example, if you see for less than 20, you have two records, 1000 and 2000, right? If you sum them up, it comes to 3000, and if you divide that by 2, you will get 1500. Same goes for rest of the groups also. And this is how we get the mean for each of the categories or groups. And now if you take the mean of this entire, all these 5 means, you will get 5500. In the next step, what we need to do is we need to find the difference between this 1500 and this 5500. 1500 minus 5500, if you do, this is what you get, negative 4000. Same thing we need to do for each of the mean. Here we are done with doing all those things. In the next step, you need to find the square of difference. Whatever the difference that you have got, you need to find the square of that, because of the obvious reason, because we want to get rid of this negativity. No, I mean negative or positive things, okay? That's where we did the square of this. Now after doing the square, next thing which we need to do is we need to find a square of difference multiplied by number of observation in each group. So square of difference was this, and a number of observation in each group, how many number of observations that we had, we need to multiply that. So for example, if you see in the category less than 20, we had 2 records. In each of the category we had 2 records. So what I have done is I have multiplied each of these values in this column with 2, and that's where I got this value. After doing this, I need to sum this up all together. So this is the value which I come up with, and this is exactly what we call sum of squares between. So whatever the difference or variance we are getting between the categories with grand mean, we are doing the square of that, and then we are doing a sum of that. That's what called SSB. Next thing, we're gonna focus on SSE. Now in this, what happens is here we try to find the difference or variance with grand mean, and over here we will try to find the variance with mean of each category and the each individual observation. What does that mean? So let's say what was the mean for the category where age is less than 20? That was 1500. So we're gonna put that over here. Similarly, I have given the mean for each of these categories over here. Next, we are going to find the difference between these two. Means 1000 minus 1500. What we are left with is negative 500. This is what we get. And then the next thing which we are going to do is find the difference of these two, right? Means the difference which we just got, we need to do the square of that, to be honest, okay? To be frank. And then find the sum of that. So this is the sum which we get. We are done with the first stage, SSE and SSB. So SSB is nothing but the variance between the groups. SSE is nothing but the variance within the group. Just keep that in the mind. In the next stage, we are going to find the degree of freedom. In chi-square also, if you remember, we had calculated degree of freedom, and here also we are going to do that. So first we will find degree of freedom within groups. What is the degree of freedom that we have within each of the group? Okay. For that, the formula is number of observation, number of total observation that you have in your data, minus number of groups. So number of total observation which we have is 10, and number of groups, which means categories, that we have is 5. So 10 minus 5 is 5. That's what our degree of freedom within groups. So 5 is the degree of freedom within groups. Now degree of freedom between groups. So for that, the formula is number of groups, which is 5. Here we just found minus 1. That's it, right? And that we get 4. We are done with finding the degree of freedom as well. Hope you are good with this. Next step, we are going to find the mean square error for this part. All right, for this part within group. And for that, the formula, and we will also find mean of a square between groups also, right? So let's focus on the first one first. So here we simply need to do SSE, which is sum of a square error divided by degree of freedom within group, and that we get 25 lakh divided by 5, which is 5 lakh. Then we need to focus on the second part, which is mean square between MSB, and that is simple, SSB divided by degree of freedom between groups, which will be 8 crores divided by 4, and we come up with approximately 2 crores, right? So we got MSE and we got MSB. This is important thing to calculate the F statistics. With this, we come up with calculating the F statistics, which is nothing but MSB divided by MSE. Guys, the calculation is very simple, right? It's just these steps are multiple. That's where you might find it little confusing. I don't think it's confusing, but if you're getting confused, you can watch the video in slow speed and you can repeat this also. Now let's focus on the calculating F statistics. So to calculate the F statistics, MSB divided by MSE, which is nothing but 2 lakh divided by 5 lakh, and then this is what we get, which is 40. That is the F statistics. Next thing which we need to find is F table value, right? F table value, like in chi-square also, you saw first we find the chi-square calculated value, and then we tried to check the chi-square tabular value. Same way we also need to find the F value by table. So let me just open the Chrome, and here I will try to find the F statistics. F statistics table. All right, here we got this. So significant level alpha value which we had taken was 0.05, if you remember. All right, so this is the next table which we got, and into this df1 is nothing but this degree of freedom between group. This is df1 and this is df2, right? So df1 is 4 for us and df2 is 5. Let's try to find df1 is 4 and df2 is 5, which means this value 5.1922. So this is what I have got. Now what you see over here is F statistics calculated is greater than F statistics tabular, which means the null hypothesis can be rejected. What does that mean? That means alternative hypothesis is true, which means age is having strong relation with loan amount. So that's why we just proven that age is having strong relation with loan amount, and that's where we should make sure that we keep age feature in our model training data. All right, hope this calculation was clear to you. Now let me take you to the Jupyter notebook and help you understand how you can implement and how you can do the feature selection using ANOVA analysis, which is analysis of variance using in Python, right? So first of all, what you need to do is you need to make sure that all of these dependencies are available. All of these dependencies are imported. Next, here I have this data. I'll upload this data on GitHub and I'll share the link with you. Next, we need to first separate the independent features and the target feature. So here I'm going to say features equals to df.drop, and inside that I'm going to say loan amount access equals to 1, and then target feature is nothing but loan amount. Hope this is clear. Next thing, we need to convert this because these are alphabetic values, right? So I mean the character values, so we need to convert that into the numbers. So for that we are going to do the label encoding, encoded, and this is something I would say pd dot data frame. I'm just creating a blank data frame, nothing else. And for I in df dot columns, here I would say encoded, here I would say I equals to df ali dot fit transform. Now let me show you what is ali. LE is an instance which I have created for label encoder. You see, label encoder I imported from preprocessing sklearn, right? So that is what LE is. Here I'm simply trying to do the label encoding for all of the features, and for that we need to use this method which is fit transform, and inside that I need to apply the I need to supply the features. Okay, that is it. Let's just see here. Okay, I just missed I over here. All right, there seemed to be some error. Why should be a 1D array? All right, so here I have given the whole data frame, which is not correct. Now what's the problem? Should not have been the problem. Encoded le.fit transform features. Already the mistake which I have made is here I should say features, because we are doing the encoding for the columns available in feature data frame here, right over here. Okay, now that is done. Let's just have a look on this data, encoded.head. Here is what we got. All right, next thing is split this data into trend test split, and for that I have imported trend test split over here from sklearn model selection module. Okay, now let me just quickly say train test split. Inside that we're gonna say encoded and target. Test size 20%. If you want to get the value exactly same what I have, then you're gonna put this parameter value same as I'm putting, and then the random state you can say 1 to 3 or 42, whatever you want. And over here you're gonna say x train, x test, y train, y test. All right, this is done. Now the next thing is to perform the ANOVA analysis, and for that we have imported over here one more module that is called select k based, right? So let me just try to create an instance for this as well. Select k based. So function which we are going to use is f regression, because here the target feature is continuous, so we would require to use f regression. If this would have been a categorical one, then we would require to use the f classification. Okay, but over here this is the function which we will be using, and this is the method which we are going to try. Select k based. Let me just try to use this select k based. And if you see the parameters here, it asks for score function, right? And let's just apply score function. Score function equals to f underscore regression, and k, they simply ask how many features that you want, out of which you want to find the select best. Okay, And for that, what we need to do is, here I will simply say all, and here I can say best features. Best features is the instance created. Then we need to say best features dot fit, and inside that we need to supply our list of features, which we are going to perform on X-train data. Remember, not on the test data, to avoid the data leakage or overfitting. And here I'm going to put Y-train. All right, this in. So now because this is done, I would store this in a variable. Let's call that selection. Okay, and inside this selection, here I'm going to find scores. You see, this is the score we got for each of the feature, and there will be another thing which is called p-value. This is the p-value which we got. Like we know, lesser the p-value, the better the feature is, and greater the score, better the feature is, right? Scores. So this is what we got. Now let's just put that into a data frame. Okay, pd dot data frame, and over here I'm going to zip three things, which I would say features dot columns. I'm just trying to zip this all together. Okay, features dot columns, and then the next one is, I'm simply trying to supply three lists into this. Okay, nothing else. And then I would say selection dot scores, and then the next thing is selection dot p-value. All right, so zip is done, and then I need to supply the columns, and into this column I'm going to say features, then f score, or rather you can say ANOVA score. I'm simply going to say it score, and then p-values. All right, this is done. Selected score, selection score, or let's say ANOVA score. And let's try to print this. All right, this is what we got. Let me just sort it. Sort values by score ascending equals to false. Bravo, we just got this. Now you see it says age and income are something which are very, very important, and that has high influence on the target feature. So we should consider keeping this, and you can consider dropping these two because these are having higher p-value. So you can feel free to drop these two, and you can continue with this. So what does that mean is, from X train, in the X train you should keep these two. I mean, in X train you should drop these two and keep these two, and in X test also you should perform the same thing. What you should notice is, here I perform this ANOVA analysis on X train data only, not on the entire data. But because when you are trying to keep or drop the features, you should do that on both of the data set. And after doing that, you train your model and then test the performance of the model. If you want me to do that, just let me know. I'll do that, and then I can share that with you. Now that we are done with all of the feature selection techniques which are considered under filtered method, now the time comes when we move to the wrapper method. And in the wrapper method, the first technique which we're going to learn about is forward selection. Let me show you how it works. So let's say you have this data set, right, with one independent, which is none other than lone status, the one which you see with thick border, and then remaining 5 independent features. So with this, as usual, whenever we are building the model, we split the data into part. One is target and the independent feature. So here comes the target feature. Now what we're going to do is, out of the remaining out of all the 5 independent features, we're going to pick each feature one by one, train the model, take the note of accuracy or any report, whatever the scoring technique you want to use. Here we are going to use accuracy, and take a note of that, and then proceed further. Let me show you step by step. So here in the center, you see this is our target feature. Now out of the independent feature, I'm going to pick one, let's say young. right? And train the model with this young feature and calculate the accuracy. Take a note of that. So for young, we are getting the accuracy A3. We're gonna then in the next iteration or in the next training, we're gonna remove this young and train the model with next feature, which is male. Now over here you see we are left with 3, and here we have the male. We are going to train our feature with this particular feature. We are going to train our model with this particular feature and take note of accuracy, which is A1. We're going to repeat the same thing with all the remaining features one by one and take note of the accuracy for each of the training. So this is what we get, the one which you can see at the right hand side. Now have a look, out of all these 5 features, which one is having the best accuracy? None other than this, which is non-graduate. Means there's a feature which is named as non-graduate, which simply tells whether the applicant is graduated or non-graduated. If it is 0, means it is non-graduated. If it is 1, sorry, if it is 1, that means it is non-graduated. If it is 0, then it is graduated. Okay, so this is how the data is, and this feature is performing the best. Now in the next iteration, what gonna happen is that best feature we are going to keep static, right? We are not going to get rid of that. We are going to keep that fixed, and along with that, out of the remaining 4 features, we are going to use one by one each of them and see in combination with non-graduate how each of these features are performing and which pair gives us the best accuracy. So let's try that. So first of all, again, we are going to, with non-graduate, we are going to use young and train the model, take the note of accuracy. So this is what we get before, right? Next, again, we are going to do the same thing with next feature, which is male. So this time we are training the model with non-graduate, of course, which was there, and male. So with non-graduate and male, we are training the model, finding the accuracy, taking note of that. Same thing we're gonna do with the remaining 2 features again and take the note of the accuracy. So which we get B1 and B2. So altogether, if you see, the feature which is performing the best is non-graduate and young, right? So that's the best pair of feature which we found in the next, in the second iteration. This process continues till the point from where we start seeing the decline in accuracy, right? There will be an optimal point. After that, the accuracy will start declining. So what will happen is in next iteration, you would have this pair fix, and out of the remaining 3 features, one by one you will try them. So in that iteration you will get 3 best feature, then again in the next one you will get 4 best feature. You would require to continue that till the point after which the accuracy starts declining with the set of features, and the point where it starts decline, that's the optimal point, and that is where you get the best set of feature for your model to perform best, right? Now let me show you this thing in Python. How would you implement this? So here in Python, let's say simply import pandas as pd and then import numpy as np from sklearn dot linear. It is auto completing, so let's just give it a few seconds to complete it automatically. So out of the linear model, we'll be picking the logistic regression to train our model. Okay, linear model, import logistic regression, and then from sklearn dot model selection import train test split. All right, there would be one more library which we would require, which is from ml extend dot feature selection import sequential selector. Now in case if you don't have this particular module already installed, so what you're going to do is take this, and over here let me first import this all, and after this what you're going to do is you can simply say pip install this and just hit Control Enter. it will be installed. Okay, so because it is already installed in my machine, I'm not going to install it. Okay, now after that I need to import the data, which I'm going to say pd dot read excel, and inside this I have this path already available over here, so I'm going to take this one. I'll just copy paste this in order to save the time. All right, we got this. Is that all right? Yes. And after that I'm going to see df. Why is that so? Oops, sorry, this was something not accurate here. So this is what we got. Now out of this, what we need to do is, you see this id variable is not needed, and diagnosis variable is something which requires to be binary. Okay, so let's just get rid of this id variable. Df underscore new equals to df dot drop, and inside that I'm going to say id access equals to 1, and let's just check df underscore new dot head. I think that is gone, right? Now let's do the next thing. In next step we need to convert this into binary. Okay, so for that what I'm going to do is df underscore new, and inside that I'm going to create another variable which is called diagnosis. Let me paste that same name from here till this, no, not till this, but just right over here, and here I'm going to use np.where, and inside that I'm going to say if this thing equals to m, then say 1, else say 0. All right, so this is what I'm going to do, and let's just see how it works. Dot head, bingo, I think it is done. Now let's just quickly check the shape of the data. Alright, df dot, first of all let me check if it has any null value. Is null dot sum. Let's see how it works. Alright, over here I need to use this one. So there isn't any feature which is null. Now you see how many features these are. Let's just check that out. Dot shape. So if you see, there are 39 features, which is quite huge to train a model, right? What I'm trying to get is I'm trying to find the top 5 features which will help me to build a model which performs the best. That's exactly what I'm going to achieve over here. So for that, I'm going to say feature selector. I would just create another instance. Let's say feature selector, and over here let's just say sequential selector. Inside that, so there are many parameters which we require to specify over here. So first of all, estimator we will require to specify, then number of features, how many features we want, then whether forward selection, floating, and verbose and scoring, and this CV. These many features we can start with. Okay, let's just start with these many features. So instead of estimator, why didn't it took? Okay, so instead of estimator I'm going to say logistic regression, because that's what my estimator is, which I'm going to be using over here. Okay, and then after that these are the sets which I would require to use. Now don't worry, I'll explain you what exactly these all mean. So what you see over here is k features, means how many features we want to select. So like I said, I want to select the top 5 performing best. Okay, top 5 best performing features. So that's what I wrote over here. I want to use forward selection method, so forward equals to true, floating equals to I'm going to keep false. Verbose is nothing but it gives you the detail of, I mean, by the time when your model is training and it is doing the selection, it will show you the detail. I mean, which iteration is it running, how is it performing, etc. Let me show you. So the more number you specify over here, the more details you will get. So I'm going to put 4 over here. Then in accuracy, which method you want to use, sorry, for scoring, which scoring technique you want to use. So like I said, I would be using accuracy over here. and this is nothing but the cross validation. So 5 cross validation I want to perform over here, so that's why I have 5. Now next thing which I'm going to do is fit, and inside that, oops, I made a mistake before this. Before we start doing this, we need to do a train test split. Train test split, and inside this, we don't need to waste time in writing this in text manually. We can simply do shift tab, and then we will come over here, and you can copy this and then just paste it over here. Yeah, so this is done, and this we selected. This test size, it is 33%. I will just make it 20%. Test size I'm going to keep 20%. Random state 42, we can live with it. That's not a big thing. Okay, now over here, this x, instead of x, what exactly that we want to use? We want to use the whole data set except the target feature. So df new dot drop, and target feature was diagnosis, right? So let me just use this one, diagnosis, access equals to 1, right? So what I'm going to what I'm trying to say is, in x, use this data set which is set of independent features. Now in place of y, what I'm going to do is, I'll require to keep only this feature, which is none other than just target feature, which is diagnosis. All right, I think it is done. Now let's just see, for example, dot head. Yeah, we are pretty good. And in y train, what is it that we got? We should have one feature only. Yeah, we are pretty much sorted, right? And now over here, I'm going to use x train. Let it complete automatically, and then we will be x train, and then I'm going to use y train. And now the time comes, we should hit enter and see the magic. All right. So like you can see, what it has done is, it has selected the five set of features, right? Okay, set of 5 features. That's what I want to say over here, right? And over here, it is trying each of the features one by one in combination, and then it is giving you the accuracy also, right? So with first feature, it is giving 91%. With second feature, it is giving 94, right? That's how it is increasing. Fourth feature, and after that it is giving you lots of warning messages or etc, lots of other information. And this is the feature of, this is 5 out of 5. With all of the feature, it is giving 95.6% of the accuracy, and over here we have 95. So more or less both of these two are same. Now this is where it has given us, it has trained the model, and it has concluded that which set of feature we should be using. I mean, what is the best 5 features, right? So how do you know that? So now this is done. Here it is just giving you the numeric information, but how do you know which set of features you require to use? So for that, let's take this instance over here and say dot, and over here feature names. You see over here, this one, feature names. Let's just, oops, not this one, feature, let's just, feature selector is here. What exactly? Feature groups, oops, not this one. Oh, no, let me just tell you this. I'm just fixed features. I think this is what it is. God, why I'm using. What we are looking for is k feature names. Okay, so these are the 5 features which we require to be using. So you see, these are the 5 features. So radius mean, these are the 5 features which we require to use, which will perform the best. Now there is one more thing. What you can do is, this is the 5 features. You can also bring some sort of flexibility. For example, I want to say to this particular selector method that give me minimum 5 features and a maximum of 10 features. In between that, give me what is the best set of the features, right? uh, I have 31 in total. Now out of 31, I want model to select uh, some set of features between 5 to 10, right? I want to leave it to the model only. So for that, what I can do is I can provide a tuple of that, so 5 to 10. Now let's just run this. Oops, this seemed okay. It require a comma over here. Now let it just run, and let's see how many features it is going to give us. So at first it is giving 91, then at second feature it is giving 92, third feature 95, fourth feature 95.6, and let's go down. Fourth feature, and where is fifth feature, man? Let's get going. So what you should do in beginning is you should put the warning. You should ignore the warning. You should put something which ignores the warning. Okay, I just made a mistake. I didn't put that particular line, and that's the reason I have to go through all these warning messages. It doesn't make sense. Let me come down over here. All right, so at 10th, with all of the 10 features, it is saying 96% of the accuracy. Now in between somewhere, let me do one thing. Let me just put the let me just ignore the warning first over here. Import warning. Done. Let me run this again. Again, with first feature, this much of the accuracy. Second feature, 94.2. Third feature, 95.16. Fourth feature, 95.6. Come on, with fifth feature, 95.6. Similar one. Exactly the same. On sixth feature also the same accuracy, right? On seventh feature also you see the same accuracy. So now what you observe is with at fifth feature it has, I mean after fifth feature it is giving us the similar accuracy, right? On eighth feature it has increased slightly. On 10th feature it has increased more. Now let's see what is the best set of feature it is giving us. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10 features it is saying that those are the best. Okay. I mean, this is how you can keep on trying. If you want, you can put 20 over here and then you can again try what is happening. Okay. So let's just see what happens over here. It's kind of interesting. That's why I'm just recording everything. I know the video is turning out to be a little lengthy, but let's just see what is it that we're gonna get. Whether it is going to tell us that all the 20 features are useful, or it is just going to tell us that use some specific set out of those 20. So with fifth, this is what we are getting. With sixth features, with six feature, this is the accuracy which we got. With seven feature, this is what we got. Let us just calculate. God, we have given too much of the load. Let's just see. On eighth feature it is giving 95.8 again. On 9 feature, with 9 feature also it's the same accuracy. With 10 feature, like we observed previously. Now let's see what happens on 11 with 11 feature. With 11 feature it is giving us 95.8. So you see it has started to decline. After 10th feature it has started to decline again. Now I'm anticipating that at the end it will give us again this 10, I mean this set of the features. Again it has increased over here. While it is training, I'm going to take a screenshot of this so that we could see what is the next set of features it is going to give us, right? I've just taken the screenshot of this part. Now on 17th feature, with 17 feature, it is giving us this much of the accuracy. 18th feature, again the same accuracy. On 20th feature, again the same accuracy. Let's see what is it that we are going to get over here. Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Okay, so we said give us any number of feature between 5 to 20, and it is giving us 15. It is saying that these are the 15 features we should try uh, in our model building. So well, this is how you can perform the forward feature selection to find the best fit of the features for your model training. If you want, you can put the range of directly 5 to 31, and out of that you can get the most best performing feature. All right, I hope this was easy for you to understand and interesting as well. Just in case of any doubt, put that into the comment section. I'll definitely try to respond to that. Now that we are done with forward selection technique, next comes is backward elimination. So what exactly happens in backward elimination? To understand this, let's recap and recap the back forward selection first. Okay, in forward selection, what happens is we start training our model with single feature, right? And we take a note of the accuracy. We keep on doing this with each of the feature, and after that we start combining the features, and we again take the note of the accuracy. At the end, whatever the best set of features gives us the best accuracy, that is the set which we use in our model training and etc. Opposed to that, in backward elimination, we start with a whole set of the features. In back forward selection, what happened is we started with one feature. In backward elimination, we are starting with a whole set of the features that we have in our data set. For example, here you can see we have 5 independent features, one dependent or target feature. Now when we train the first model, that we will train with whole 5 set of the features, 5 independent features. Okay, and we will take a note of the accuracy. So for example, here is the 5 features, and let's say with this we trained our model, and model 1, let's say that model 1, and that gives us the accuracy of A2. In the next iteration, what we're going to do is, out of this we will remove one feature. Let's say we are removing young, right? We removed young feature, and we are left with 4 features, and with that, let's say we are training the model, and this set of features gives us the accuracy of A3. In the next iteration, what we're going to do is we're going to remove male, and then again we train the model, and then in that we get A4. In the next one, what we're going to do is we remove the next feature, and with remaining 2 we're going to get the accuracy, and that is A1.3. In the next one, we're gonna again remove one, and this time we are left with one feature only, and when we train the model, this is what we get. We are getting the accuracy of 1. Now like you can see, as we keep on eliminating the features, it keep on over here, it keeps on increasing the accuracy with best set of the features, but after certain point the accuracy starts to decline, right? That is the point where we have best set of features. So that is none other than model 3, third model, which is giving us the accuracy of A4. So this is how the backward elimination works. Hope it is clear to you. Now let me take you to the Python and help you understand how we can implement it in Python. So for that, let me take you over here. So first of all, let's import all of the dependencies. So for this, you would require one library, which is ml extend. This is something which you would require to install in case if you have not done that already. Pip install. This is what you need to do. If you have seen my previous video, means you have already installed it. If you have not installed it, means you have not seen my previous video. So either of the situation, in either of this situation, that's absolutely fine. You just go ahead and install this in case if you don't have it already, right? Because I already have it, so I'm not going to run this command, right? And over here I'll just comment it. Now next I'm going to import pandas as pd, import numpy as np from sklearn dot model selection, import train test split from sklearn dot linear models. It should say Come on, give it to me. sklearn lin. Okay, there is a spelling error. Learn.liner linear model import logistic regression. Fortunately, let me do this again. Logistic regression, this is done. Now then, from ml extend dot feature selection import sequential selector. Now last but not the least, then we are going to say import warnings. This is just to avoid the unnecessary warnings which we don't require, right? And I'm going to say filter warnings. This has again the spelling error. Ignore, I'm going to set it. Next thing, which ignore NORE. I keep on doing these spelling mistakes. Please bear with that, okay? pd.read excel, and inside that I'm going to use this. This is the file which I want to use, and I'm going to say df.head, and this is how the data looks like, okay? And like you can see, it has 31 features, out of which 30 are going to be independent, and this diagnosis is going to be dependent, which is target variable, right? Now let's just quickly check if we have any missing value. Is null, and over here I'm going to sum it up. So like you can see, this doesn't have any missing value. All of the features are showing 0 missing values, right? So we are all set. Next, we are going to split our data in train test split, and let me just copy the syntax directly from here. There is no point of wasting the time in writing that, okay? So what I will do is I will go into this, and for this one we have the whole syntax right over here. You can just copy paste over here. If you want to write, you can of course write. My advice is that if you are beginner, you should write it, okay? Then over here I'm going to say df.drop, because see here in training x set, I want to keep whole data set except the target one. So over here I'm going to say diagnosis. I'll quickly copy it from here so that we don't get into the spelling error again, otherwise that will unnecessarily waste the time, okay? And here I'm going to say x is equals to 1. In the next one I'm going to say df dot keep this feature only. That's what I need to say. Next one is I'm going to create an instance, which is, let's say that feature selector, okay? And over here I'm going to call that sequential feature selector, the module which we had imported in the beginning. Now for this, the parameters which we need to provide is, first we need to provide the estimator, which will be your model, whatever model you want to use, because we have to train our model with each set of the features, right? So we need to tell this which model we want to use. So here I'm going to use logistic regression, so that I have given over here. Now here I would tell it how many features I want to select out of the 30 which we have. So for that I'm going to say k underscore features, right? So that is 5 features I want to select over here. So why? Because if I don't put it, it will at the end it will give me one feature, which is best, right? So but I don't want to train my model with single feature, so here I have decided to keep at least 5 features. Now after that, very quickly, what I'm going to do is, this is very important, you should set it to false. If you don't set it to false, then it will do the forward selection method. That's why I'm saying forward equals to false. Then comes the floating I'm going to set as false. Then comes verbose is because it will tell us what is happening in each of the iteration. So you can put any number over here. The more number you keep over here, it will give you the more detail. If you put 0, it will give no detail, okay? I'm putting 5. Then you need to provide how many cross validations that you want to do. So I want to do 5 cross validation. After that I want to fit my model, and for that I need to provide x train and y train. All right, now the moment I execute this, it will start training the model with each different set of the features, and it will give us the information also. Like you can see, it has started and it says 5.6 seconds has elapsed. It started with 29 features because training the model with 30 features, that is already internally done, right? So in the next iteration it is starting with 29 features, and out of that it is trying to estimate the 5 feature which will be best, and with that it is giving us the accuracy of 94.48. So here it is by default giving us the accuracy. There is one parameter which is called a score that you can also use. I mean, you can use the score parameter, and into that whatever you want you can put, whatever the scoring technique you want to use you can put that. For over here I have went with the default one, right? So this is how it will keep on training. So it will do this thing for all the 30 features till the time I'm going to pause this video. All right, everybody, we are, I mean, this is done with, training the model with each different set of feature, and at the end, it has ended it at 5 out of 5, right? Now, let's just see at what point it started to decline, from which point it started to decline. So, like you can see over here with 19 features, when it trained it with 19 features, it gave us the 96.32% of the accuracy. And over here, it was the best one, right? And then it started to decline. Now let's just see what is the best 5 features it is giving us. So feature selector, that is our instance, and out of that I'm going to check k feature names, and this is the set of features which we get over here, 1 2 3 4 5, and this is what we would require to use in our model building and so on. Now that we are done with backward elimination method, next which comes in the queue is recursive feature elimination. What exactly it is? So the meaning is very simple. Recursive feature elimination means removing the features iteratively or repetitively till the time when you reach the desired number of feature which you needed, desired number of most important feature which you needed to train your model, right? So let me explain you with example. Let's say this is your data which has 5 independent feature and one target feature which is lone status. Now in the first iteration what happens is it takes whole set of data and trains the model, and it gives you the importance of each of the feature. And now out of this list you would realize, or it finds the least important feature. Here you can see that is none other than this one, which is male, which simply says whether the applicant was male or female, right? So this is the least important feature. So what it will do is it will remove this feature from this iteration. Now these steps will be repeated till the time we reach to the point where we are left with only those number of features which we had asked for. So the question comes in how this importance is decided. So there are models like decision tree or logistic regression, etc. In decision tree you get a property which is called feature importance. So this is the property which is leveraged to find the importance of each of the features. So how does exactly it works? When you train the RFE, it takes 2 parameters. One is which model you want to use for this RFE, which is recursive feature elimination, and then how many features exactly you want to be selected, right, out of this entire process. So let's say I want to select, here I have 5 features, and out of that I want to select 3 most important feature. So over here I will write 3, and over here the model which I want to use for RFE is decision tree, for example. So I will put decision tree. If you put logistic regression, then RFE will utilize the coefficient thing, right? Logistic regression has the property of coefficient that will be utilized. So this is how in nutshell the recursive feature elimination works. Now I'm going to show you how to implement this in Python. So let me show you it over here. In interest of the time, what I have done is I have already imported all the dependencies. So here I have imported 2 recursive feature elements. One is recursive feature feature elimination with cross validation, and this is just recursive feature elimination. I will be showing you this one, and I would suggest that you should go ahead and try this one. Okay, now here I have imported the data, and here you are seeing the whole set of data. This is our target feature, rest all are independent features. So in total we have 31 features, out of which one is dependent or the target feature, remaining 30 are the independent feature. Here what I have done is I have done the train test split of the features, which we train test split of the data, not the features, train test split of the data, which we usually do before starting to train any of the model. That's exactly what it is. Right now I'm going to create the RFE. So for RFE, I'm going to create an instance called RFE select, and inside that I'm going to use RFE. Inside that, it is simply asking me to provide the estimator. Estimator means you need to tell which model you want to use. So here I will be using decision tree, and here it says number of features to select, how many features we want to select. That's what we need to tell to this particular model. So here I'm going to use decision tree classifier, and the number of features which I want to select. Let's say out of 30 I want to select 7 features. Okay, out of 30 I want to select 7 features. Now over here I would require to say fit, and here let's say x train and y underscore train. That is it. Now after this it is going to complete the task. It gives some error, missing one argument, self. What is self? Okay, let me see if this is executed or not. Why it is saying self? Missing one requirement, positional argument, self. Alright, so the problem is here the way I have written decision tree, because I'm creating the instance, right? So I need to write it with parenthesis, right? Now let me just run this. This is done. Then the next thing which we're going to do is RFA.select RFA underscore select dot. Here there's something called support. This one, right? And when you do this, what you're seeing is, see, for rest of the features it says false, 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 means those are not much important. But this set of the features, these all turns out to be the important features, right? So now let's put it in the form of data frame. So here I'm going to say important features, and let's see what all are the important features that we need to, along with the name. Here we don't know which name, which feature name is true, etc., right? So that's what I'm going to simplify over here. So there is something called zip to concatenate two lists, right? So first list which goes is xtrain dot columns, from which simply mean is out of the training set of data I'm fetching all the list of the columns. And then the second list, in the second list I'm going to take this one, and then I'm going to convert it into the list, and then I'm going to put it in the pandas data frame. All right, now over here and here, because if we are converting anything into the pandas data frame, I need to provide the column names also, right? So here I'm going to say features, or you can also say feature name, and here I'm going to say importance, important or not. That's it. Now I'm going to say important features, and let's just see. All right, now let me just sort this also. Let's say sort values, and inside that by important and ascending, because I want to sort it in descending order, so I would say ascending equals to false. So now you see these are the 7 features which are most important to train our model. Rest everything is least important. Now when you are doing this, here we said 7 features, which is very much fixed, right? If you want, you can also say that I require 0.25, which is 25% of the features. All the features, let's say there are 100 features, then it will give you 25 features out of that. If there are 200, it will give you 50 features, etc. So 25% of all the independent features I want to select into it, right? So that's what it will happen. Now over here you see again we got 7, because 7 is 25% of approximately 25% of the 30, right? So this is how we implement the recursive feature elimination in Python. Hope it was easy to understand. Just in case of any doubt, put that into the comment section. I'll definitely try to help you out. Now that we are done with recursive feature elimination, the next which comes in this series is these two, sequential forward selection and sequential backward selection, and implementation of these two are quite similar to these two which we had learned in the beginning itself while we started with wrapper method, which are forward selection and backward elimination. Hence I'm going to leave this on you please go ahead and try to implement this. The implementation is going to be exactly the same, right? So I will skip this to one and I'll directly jump to the embedded method, and out of that we are going to be talking about lasso regression. So lasso regression is something we also use to train the model. Here we are going to see how to use this for feature selections, right? So for example over here what you see is, let's try to understand this with the help of an example. So in example, let's say this is your data which has one target feature called loan status and 5 independent features. Now what lasso regression does is, first it finds the coefficient for each of the features and does the scorings. To find those coefficient, it uses linear regression. So if you see, this is how, let's say this is how it does the scoring. So these scoring which you see are not the real scoring which came out of training the model. These are just the hypothetical numbers, for example. Okay, so what you see, young has score as 3, low has 4, etc. Now after this, lasso does the shrinkage of the features by penalizing them with lambda. So let's say the given value is 1, by which the feature will be penalized. It's very simple, right? So in this shrinkage, it is simply lambda is subtracted from the initial score, and this is how we get the new coefficient. So what you see is new coefficient equals to x minus lambda, where x is the initial score minus lambda is this value. So this is what we get. Now once you do this, you notice this particular feature which is male, with this feature simply says whether the applicant was male or female. This has the new coefficient as 0. So the moment we see this as 0, the lasso regression by default eliminate this feature. So this is how it eliminates the feature which are less value add and keeps those features which are more valuable. So you see these two are the strongest feature into this, and these two are also contributing well. So this is how we come up with the specific set of features which are needed for our model building, right? So hope this was clear to you. I'm not going to get into too much of the mathematical terms. In case if you are interested in learning lasso in lot more detail along with the mathematical terms, do let me know. I'll make a separate video. Now I'll take you to the Python. I'll show you how to implement this. So for that, what I have done is I've already imported the dependencies. The things which you require is to have the train test split. Then this lasso you need to import from sklearn and linear model. Okay, then standard scaler I have imported because I would require to scale my data as well, right? So whenever we are working on lasso, it is recommended that you look at your data and see scaling is important or what, right? Mostly this is important, right? So we should be using that scaling thing, right? Now moving on, though here the features are quite in same parameter, same measurement. Usually what happens when we need to do the scaling is, let's say in your data set you have one feature as age, the other feature is as salary. So salary number which you see in salary, digits which you see in salary will be quite higher than what you see in age, right? So at that point of time, scaling becomes more critical to do, and what I mean is more important to do, right? But over here it should still be fine, but to be on safer side, I will be doing the scaling of it also, right? Now moving on over here, so what I have done is I have splitted the data in target and independent feature. Now after that I'm going to do the scaling for that. So for that I had imported the scaler, and I'm going to create an instance for that. Okay, first of all let me run this, and then here comes the scaler. All right, this is done. Now the next part which comes is x scaled. I'm going to create x scaled, and for that scaler dot fit transform, and inside that I need to provide my data which is x. Now my data is scaled. Now I will require to do the train test split, train test split. And for that, as you know, I always do this: shift tab, go into this and copy the syntax from here, because I don't really want to use the time which in something which can be done very easily. So there is no need to hesitate in copying it from the description. Now over here I have x, so I will replace x with x scaled, and y I'm going to keep same. Right now, after that, the data is splitted in training and testing. Now next thing which we need to do is create the instance for lasso. So I'm going to say lasso instance, and over here I would say lasso, and we need to put some value for alpha. So I'm going to use that value as 0.1. right? You can, it completely depends on the scenario. Right here I'm keeping 0.1. You can, you may like to keep it a different one. I would suggest that you try this with different values. Right here I am going to show you the example with 0.1, but my recommendation is that you use different values over here and try it again. Okay, now once this is done, in the next one what I'm going to do is lasso instance dot fit, and inside that I'm going to say x train and y train. Well done, we are done with this. Now we will see the coefficient of the features. Let's say coefficient, and let's see, this is the coefficient which we have got. Now what you observe over here, almost all of the features are having coefficient 0 except these four. Right, except these four, everything is having coefficient of 0. So what we observe is these are the only four features which we require to train our model. Now let's see what are these four features. So in our data, which is x, we can fetch the column names. These are the columns, and along with that we can concatenate these values. Right, then we will get which feature are selected. Okay, and wherever it is 0, I'll remove them simply. Okay, now let's just try. Let's just say selected features, and here I'm going to say feature for feature comma coef in zip, and inside zip I'm going to say x dot columns comma lasso instance dot coef. So what I'm doing is I'm taking all the columns from x dataset and lasso and coefficient from this lasso training which we have just done, lasso fit which we just did. Right, and this is it. Now here I would put one more parameter. If coef, here I'm iterating through it and I'm saying if coef not equals to 0, then only give me those things. There seem to be some not network issue, but the syntax issue. Okay, I think that is done, and now over here I can just see what are the features which have been selected. So these are the most four important features which we should be using in our model building. Right, so this is how you can use the lasso regression for feature selection. Hope it was simple and clear to understand. In case of any doubt, put that into the comment section. I'll definitely try to help you out. Now that we are done with lasso regression for the feature selection, the next one which comes in the queue is Riz regression. Right, let's just understand what exactly it is and how does it work. So Riz regression is pretty much similar to the lasso one. The difference is Riz regression never does the penalization and zeroize the new coefficient. Right, so it will never make it 0. So this is little lenient, where lasso regression is pretty aggressive. Right, the lasso regression is pretty aggressive. It zeroizes the new coefficient, where in Riz regression it gives you the value which can be close to 0, but mostly it doesn't gives the new coefficient as 0. Why does it happens? Lasso regression penalizes the absolute value of the coefficients. For example, this was our original initial coefficient, and when it does the penalization, it did the penalization on initial absolute coefficient score directly, while in Riz regression what it does is it does the penalization on the squared squared coefficients, right? Coefficient, that's what the main difference is. Hope it has clarified. Now instead of going deep into the mathematics of this thing, I would directly take you to the Python and I will show you how to implement res regression in Python. Let me take you to the Python. So here we are in Jupyter Notebook, and like you can see here, I have already imported all the dependencies which are needed: trend, test, split, range, and standard scalar. The same data which we had used for Lasso, same we are going to use over here as well, which has 31 columns and 5 rows. We splitted that into independent and dependent features. X is the set of independent features which will help in predicting, and Y is the target feature which we also say as dependent features. Now what we will do is, first we will do the scaling of this data, okay, which is independent features, right? So for that we require the standard scalar. Here we have the standard scalar. Let's create the scalar instance. Scalar equals to standard scalar instance is created, right? And then we're gonna say x scaled. We are going to scale the independent features, right? So scalar dot fit transform, and inside that I'm going to put the data which I need to scale. So now that is scaled, next comes is doing the trend test split of the data, right? So here I'm going to say trend test split, and I'll just press over here shift plus tab and scroll it down so that I could copy the syntax very quickly, and we would not require to spend a lot of time into writing this syntax. Right, now here we are, instead of x, now here we have the x. Now instead of x, what I'll do is I'll put x scaled, because this is the data which we are going to be using further, right? So this is done. If you are someone who have already trained few of the models, then you already understand what trend test split is, so I'm not going to get into the detail for that. Now next one comes is res regression, creating the instance for res regression, right? So here we go, res reg, I'm just going to say res reg, and then here I need range. And where did I get that? So that's something which I have imported over here. All right, you can see. Now into this we need to supply the value for alpha. If you remember, we had done this in lasso regression as well, right? This is for the regularization. Okay, now this is done. We have created the instance. Next thing which we gonna do is we are going to train the model. So for that we're gonna say reach reg, this one, all right, dot fit, and inside that I'm going to put x scaled, x train, because here x train is the dataset which contains scaled data, right? So we don't need to be worried about it. Y train, all right, this is what we got. Next thing which comes is finding the coefficient, taking out the coef out of this model. So this is the set of coefficient which we have got. Now we don't know which coefficient refers to the which feature, right? So we are going to do this. We are going to create feature importance, and over here I'm going to say feature. So we require two things. One is feature name, against that we want to put the importance, I mean coefficient of it. So here I'm going to say feature comma coef for feature comma coef in zip x dot columns comma range. This one, this is exactly what I am looking for over here. So let me explain you what exactly this is. So X is my data set. If you remember over here, I had taken the set of independent features. Out of that X, I'm only taking the list of the columns. Now here range is my trained model, and out of that I'm taking the coefficient, and I'm concatenating both, and out of that I do the iteration, right? And then what I'm going to do is I'll print it right over here. Let's just see. Here we got that. Now the next thing which I'm going to do is I'm going to convert this into the pandas data frame and sort it into the descending order, right? So I'm going to say feature FIDF, which is nothing but feature importance data frame. All right, now here I'm going to say pd dot data frame. So this name you can keep anything. Hope you are you are already understanding that it's not mandatory that you need to keep the same name. Okay, so over here I'm going to put data frame name, which is feature importance. I'll just copy it from here so that we avoid these spelling mistakes, comma columns. Column name we need to supply, and that I'm going to say first column name it as features, second column name it as coefficient. And once this is created, let me print it. So this is what we got. Now the most important feature I want to keep at the top. So for that I'm going to say sort values, and inside that I'm going to say by equals to coef, and here I'm going to say ascending equals to false, so that it sorts that into the descending order. Now if you see, these are, if you want to take top 5 features, then these are the set of top 5 features which you should be selecting for your model training and model building. Okay, so this is how you can use the utilize ridge regression for feature selection. Now point if you should notice, if you notice, is this is what we have over here. You see none of the features have the coefficient as 0. That's what ridge regression do. If you remember the previous video on lasso regression, into that we had got many features which were having the 0 coefficient. So that's where ridge regression makes the difference. I hope it was easy for you to understand. Just in case of any doubt, put that into the comment section. I'll definitely try to help you out. And now that we are done with ridge regression, the next one which comes in the queue is decision trees and random forest. But what I'm going to do is I'm going to put this thing on hold for a second. Not for a second, for this time, and I'm going to directly jump to ElasticNet. Why is that so? Because ElasticNet is something which comes next into the regression family after lasso and ridge regression. Okay, so I want to continue the sequence. That's where I'm trying to jump to the ElasticNet directly. Now let's talk about the ElasticNet regression. Before that, let's do a quick recap about lasso. Lasso is something which penalizes the sum of the absolute value of the coefficients. That's why it is considered to be more aggressive towards the feature selection. Wherever the features which are contributing less to the model building or model training, it does zeroize the coefficient of those features. While if we talk about the ridge regression, it penalizes the sum of the squared coefficient, which means it does not zeroize the coefficient of the features even if they are contributing lesser to the models. That's what mostly it happens. So it is considered to be less aggressive compared to lasso and turns out to be more effective, but that completely depends on the situation when you are applying this. Now consider about a situation where you want to have a combination of both of these two. That's where you're gonna come up with ElasticNet regression. So ElasticNet regression simply combines the features of the lasso and ridge regression and gives you the most efficient way of doing the feature selection or model building, whatever. Here we are talking about the feature selection. We will focus on that only. Now if you want to understand this in absolutely layman term, so consider yourself as a coach who is trying to build a cricket team. Now considering in that situation, if your goal is to have the expert batsman, expert bowler, everything is most expert, then that is something where you should be going with lasso. Now if you are the coach who is trying to have the sort of players who could not be an expert but good enough for that, and they have some other qualities as well. For example, somebody is good in batting and can do the bowling also, all those kind of things, it means you are little lenient, then you can go ahead with ridge regression. Now if you are someone who want to have the combination of both of these two, means you want expert of batting, expert of bowling, and some set of features who can do both of the things, or maybe they are not expert but they are good enough, then you should be going with ElasticNet regression. Hope this clarifies the concept of it. Now, because we are not getting into the model building, I'm not going to get into the mathematics behind all of this concept, and directly going to take you to the Python and show how you can implement this elastic net regression and do the feature selection. So let's jump to this Jupyter notebook over here. Here what you should notice is, here I have already imported all the dependencies. Now this is something which we need to do to utilize the elastic net. This is how we import the elastic net in a nutshell. So elastic net comes under linear model module of sklearn, right? So this is how you can do the import. Now this is how I have done the data import. This data has 31 columns, out of which one column is the target feature and the rest are independent features which will help in prediction. Okay, now I'm going to, first thing which I'm going to do is scale this data. To scale this data we require standard scaler, which we have already imported over here. Now to scale this, the instance which I would be creating is, let's say, scalar. Instance is created. Next one is do the fit transform, scalar dot fit transform, and inside that I need to supply my independent features, and this is how scaling is done. I need to store that in the x scaled variable. You can name it anything, whatever you want. Next thing which comes is trend test split. So I will do the trend test split, and for that, to copy the syntax, I'm going to get into this detail, and from here I will copy this syntax detail right from here, and I will just put it over here. Do a little bit of cleaning into this, and here x which we have, I'm going to replace that with x scaled. Now our train test split is done. Next thing is training our model elastic net. So before that we need to create an instance for that. So I'm going to say elastic net, and inside that few of the parameters which we need to supply, which I'm going to mostly keep as default. Alpha equals to 0.1. Then I'm going to keep L1 value, L1 ratio as 0.5, and random state I'm going to keep as 42. So this is something I would encourage you to go ahead and try to put different values and see how the performance gets changed. But for now I'm going to keep it almost default thing. If you would see over here, it is alpha 1.0, but I'm keeping 0.1, right? Let's just try it with this one, elastic reg. I'm going to name it as elastic reg, and let's just try elastic reg dot fit, and inside that I'm going to use xtrain, which is my data, scaled data, and y train. This is done. Now let's just find the coefficient of it. Elastic reg dot coef. Here we got the coefficient of the features. Now let's just try to put it in the form of data frame against each of the features, right? So for that I'm going to say feature importance, let's just say it, and over here I'm going to say feature comma coef for feature comma coef in zip. I'm going to take the list of columns from here, x dataset. All right, x dot columns comma this elastic reg dot coef. This is what I'm going to do, and then after that I'll try to put this in a data frame. Let's say importance data frame. I'm going to say importance df, and over here I would say pd dot data frame, and inside that this is the data frame I'm using, and for that I need to supply the columns parameter into that first column. I would say it is features, and second column is coefficient, or let me say importance, and let's just try to print this data. Ooh, this is what we got over here, right? You see, let me just try to sort this data. I would say sort values. I'm letting it do the autocomplete. Oops, it turns out that it is going to take long, but still I would require to wait. I'll pause the video. Alright, here we got this suggestion. Now I'm going to choose this thing, and inside that I'm going to say by importance. Let me just put it over here, and here I'm going to say ascending. Again I did the autocomplete. Ascending equals to false. Let's see how it goes. Yeah, so here we got this set of features. These are the set of features which the model is considering to be the best fit for our model training. So this is how you can utilize the elastic net for the feature selection. I hope it was clear. Just in case of any doubt, put that into the comment section. I'll definitely try to help you out. All right, everybody, now we are heading towards the end of this series of feature selection. In the previous video, we are done with elastic net. Next, which comes in this series, is tree-based feature importance, finding the feature importance basis on the tree-based techniques like decision trees and the random forest. So under this segment, we are going to take example of decision trees and random forest. Let me take you to the Jupyter. Before I proceed further, I'm assuming that you already familiar with decision trees and random forest. Just in case not, then I'm going to drop the link of these two videos separately into the description section. Just check that out and let me know in the case of any question and confusion. Okay, now let me take you to the Jupyter notebook quickly and help you understand how to achieve this. So here are the dependencies that we have. Now these two things which we require for this implementation. First one is decision tree classifier, which you can find in tree module of sklearn. Next one is random forest classifier, which you can find in ensemble module of sklearn. Let's move ahead, and over here we have this data frame which has 31 columns, and the same one we are considering in all of the videos under feature selection, almost all of the videos. Right now, out of this data, for not first one, maybe it could, for you it could be in anywhere in the sequence. For me it is the first one. This particular column is for target features, right? This one is set of independent features. Now let's just go ahead, and because we are going to do the tree based thing, right, this doesn't require the scaling of the data. So let me directly jump to the train test split part. Here I'm going to say train test split, and into that again I will hit shift plus tab, and from here I'm going to copy the syntax right from here. Let me do this, cleaning a bit. All right, this is done. Train test split is done. Now I'm going to create two instances. For one is for decision tree, the other one is for random forest. Let me just say decision tree d tree, and here I'm going to say decision tree decision tree classifier, and then r forest. All right, and here I'm going to say random forest classifier. Both of these two instances are created. Now next thing is I'm going to train the model, right? So let me just call dtree dot fit, and inside that I'm going to put x train comma y train, and this is done. Next training which I'm going to do is for random forest. Just don't get confused. If you want to do one only, you can of course do that, but here I'm taking both of these two in parallel, so that's why it is happening. So right, and inside this again I'm going to consider x train comma y train. Now because our purpose is to find the feature importance, not going to get into the prediction and all those things, both of these two are trained. Now let's try to find the feature importance for d3 dot, let me just find feature importance over here. You see, here is what we got. Let's see if I can get the feature names. Features, max features, we don't have that. All right, let me see. I'm trying to find that. If that's something which is going to get long, then I would leave that. So these are all set of features. It's not simply telling you the importance of this against it, but you can achieve that. Okay, now but before that, let me give you the importance of random forest, importance that we have got. Let me repeat this again. Okay, d3 dot feature importance, this is what we are getting. And for random forest, let me see what is it that we got. Random forest dot feature importance, this is what we are getting. Okay, so random forest looks like more, you know, lenient compared to the decision tree. Okay, because in decision tree for many of the features it is saying zero importance, while random forest seems to be giving some level of importance to each of the features. Now let's try to map each of these two against the features. Okay, so for that, here I'm going to say create another object, feature importance, and I'm going to take this here, let's say, okay, features comma d importance, which means here I'll take the importance from decision tree, and here I'm going to say rf importance. Let me just quickly copy this all. For this in zip, I'm going to concatenate all these three. So first of all, here is my data set. You see x. Out of x, I'm going to take set of all the features, which is x dot columns. This gives me all the features from the data set. Next thing which I'm going to do is take this one for decision tree, right? And then this one for random forest. I'm putting this one for random forest. That's it. Let me just try to run this. Okay, we got this feature importance. Let me copy paste it so that we avoid the spelling error. Here's what we got for all of the features, right? Now I'm going to convert this into the data frame, and here I'm going to say df equals to pd.data frame. So for your information, I have already imported pandas over here and defined that as pd. Okay, so that's where when I say pd, that means I am referring to pandas over here. Now I need to supply the set of column names over here. So I'm going to say columns, and inside that I'm going to say these are the columns. I'm going to keep the naming convention same as it is. Now features, and this is decision tree importance, and this is random forest importance. Right, now let me just try to print this data, and let's say head. So here is what we got, right? Let me try to sort this data first. Okay, sort values by, and because here we are going to do the sorting on decision tree importance as well as random forest importance both, so that's why I'm going to supply both of these two in form of list, and here I'm going to say ascending equals to false. Right, now let's just see how it goes. Now I'm going to take top 5 only. So here is what we got. These are the set of features which are going to be considered most important from decision tree point of view. For random forest, again, you need to do the sorting basis on this only, or we can just say, let's say 10 features. Okay, so here is what we got. Okay, so I hope this clarifies how you can find the feature importance. Finding it with decision tree and random forest is relatively easy because they themselves include one function which is called importance, which we just saw, and that's how it becomes simple. So I hope it was clear for you to understand. Just in case of any doubt, do not hesitate to put that into the comment section. I'll definitely try to answer that. And with this, we are done with this complete series of feature selection, and I highly encourage you to go ahead and make use of it. Thank you very much. Wish you very good luck.